A very good evening, students. Today, this is D. Gokila, Department of Computer Science PG in Kristu Jayanti, deemed to be University, Bangalore. In machine learning, today I am going to deal with clustering algorithms. A warm welcome to all. Let us start the session now. Clustering. So we are going to see what is document clustering and motivations regarding the clustering and document representation, and we are going to see the types of clustering algorithms like partition algorithms and hierarchical algorithms. First, what is clustering? Clustering is a process of grouping of set of objects into classes of similar objects. So the documents in the cluster should be of similars and the documents from the different clusters should be of dissimilar categories. The commonest form of supervised algorithms is that the unsupervised algorithms is learning from a raw data where it is opposed to do the supervised data where the classifications of examples is given. So that is the main difference between supervised algorithm and unsupervised algorithm. So the common important task in the clustering is being represented in this information retrieval presentation. So this is an example of dataset with a clear cluster structure where you can find that a group of icons are clustered together. Either the clustering can be based upon the distance through which the similar clusters are categorized together upon which the distances that is far away from another clusters. So depends upon that we can design an algorithms before on the three cluster case. So you can find a cluster 1A and 1B and 1C. So the applications of clustering algorithms in an information retrieval system is that it may be a whole corpus analysis algorithm where it is used for a navigation function that will give you an advantage of better user interface without searching and typing. That is, instead that if you go for Google, if you start typing some words, now Google can retrieve the basic or the balanced things is an example of your information retrieval. That is done with the help of clustering algorithms, which is one of the basic applications of the clustering algorithms. For improving the recall in search applications are also in a better applications in a clustering algorithms where you can find the pseudo segments of the clustering algorithms with RF natures, where better navigations of the search results can also be found out with an effective recall with the higher categorizations. For speeding up of the vector space retrieval, this cluster based retrieval gives a faster search for these algorithms. So this is an example of Google knows like how the clustering has been an effective presentation with the help of metaphor, where you start typing something, the balance can be retrieved from the help of clustering algorithms itself. So this is a scatter of clustering algorithms which is been formed with Cutting, Kargar and Pearson's algorithms, where you can find the different states are associated with here. So this is a visualization document collections with the non-visualization PNL themes where you can find the group of similar clusters that is arrived together. So for improving the recall, we use a theory called as cluster hypothesis, where the documents of the same cluster will have a similar property. That similar property will be respect to the relevance of the information needs. Therefore, in order to improve the search call, we use a cluster in a corpus in Prairie algorithm, okay, Apri algorithms, where the query matches the documentation D, also written other documents in the cluster containing D. So the query car will also return docs containing the automobiles that will be grouped together containing a car, thus contain an automobile. So this cluster, this might happen with the hard and the soft clustering algorithms, that each document belongs to one cluster. That will be more common and easier to do. Soft cluster, a document can belongs to more than one cluster. That makes some sense of applications for creating the browsable hierarchies. You may also put a pair of sneakers in two clusters, one is sports apparel and shoes, where you can have a soft clustering approach that you can have, do not have a soft clustering today with an important partitioning algorithms that will construct a partition of n documents with k clusters, a given set of documents and a number k, a partition of k clusters that optimizes the chosen partition criteria. That way go globally optimal and it will be interactable with objective functions. And exact enumerations with all partitions with the effective k-means centered algorithms that assumes documents with the real world vectors, and also it is clusters are also based with the centroids, where the centroids are used in such a way that it is center of gravity mean and the points of clusters can also be used here. The reassessment of the instances of the clusters is based upon the distances of the current cluster centroids that are one or equally phrased in the terms of the k-means algorithms in the clusters. And next is that the k-means algorithm also select a random number of seeds as a clusters, like starting from S1, S2 till Sk, until the clustering convergence or stopping criteria or the document is being done. That has been assigned to the cluster and it is minimal. Next update to the seeds of the centroids of the each cluster may be used here. When you go for k-means algorithms, we have, for example, two type of clusters that can be grouped together in order to give an answer. Now we can pick a seeds that which is very similar, like it is a red color or blue color, and we can group the clusters and reassign the clusters, and we can compute the centroids, reassign the clusters again and recompute the centroids again and reassign the clusters again. We form the set again and again until we find that there is no other means to replace its original position. The k-means algorithm gets continued again and again. So this is about an example of clustering and a k-means algorithms. Thank you all for listening patiently. Thank you, students.